So far for DC bore, and now we have all this data. We can use it for longitudinal sections, for example. And this is done with the program DCSECTION, which uses the data to combine all the types of constructions of borehole logs, dynamic probing, cone penetration test, or other tests can be combined to one large plan, for example. If we make a new project here, if it's the same name as in DC bore, I have to close this program first and then create the new project for DCSECTION. You can have a layout name P1. Now we have two types of plans, and in addition there are two types or two extensions of the program DCSECTION. There is DCSECTION Lite and DCSECTION Full version. The Lite version only supports longitudinal section to be created manually and without filling of the soil layers between the bore profiles. And the full version supports in addition a site plan and automatic creation of sections from the site plan, which I will show a little later. First, we have the option for longitudinal section manually. We can define a page format, and depending on your printer driver, any type of or any size of page is defined in this list here. If we have a driver which only supports small sheets like A4 and A3, we can define a larger one here, and this is automatically split into A4 sheets. We can define the scale. And now we have a plan for a longitudinal section. And you see here many graphics functions. You may as well enter a DXF file for the graphics or any map, for example, or image files like BMP or TIFF for a map in the background. And then you may add the different types of tests. The selection of the type is here under this icon, test type. And we first can select bore profiles. Here you have as well dynamic probings, cone penetration tests, sieve analysis, and so on. So we want to use bore profiles, select a project file of DC bore. And there's one important point here. We always use the latest data from the single programs. That means if we have a large plan in DCSECTION, this plan uses the data of DC bore and doesn't make any copy. So we don't have to change any modifications twice or three times. If there is something changed in DC bore for the bore profiles, this is automatically used in DCSECTION for the latest plan. Any modification is automatically used in DCSECTION as well. So we want to use this project file and select one test, one bore profile, and this profile should be located at this position here. And this might as well be some reference point, so we can define an additional distance to this point where the bore profile is located. Then it is defined here, and then we can select the second bore profile. And now for the reference point, we can use the previous bore profile. I select this one in this red circle here. And now, if we have defined the coordinates that I showed you in DC bore, the coordinates of the bore profiles, Then the DCSECTION automatically calculates the distance between the new profile and this first one here, and shows the bore profile at the correct distance here, and with the correct application height. You see here 207 meters and here 208 meters. So this is automatically placed at the correct height. The next test, next bore profile with a reference to this one also defines distance and so on. So we have a different bore profile here, and we can now add different types of tests. For example, we want to use a dynamic probing. Select again a project file from DC probe. Select one test, which might be located at this position here with a certain cross scale. And we might select a cone penetration test, for example, with a project file from DC cone. And I select a test number DS1 at this position. And then we have these diagrams and so on. So we can connect or combine any type of test that you have defined with a single test programs, DC bore, DC probe, DC cone, and so on. Now we can add the filling of the different soil layers. I'm making a zoom here for this area. And first of all, this may be an arbitrary polygon, for example. So if I use this function here, filling, I could define here 4 points, for example. And when I go back to the starting point, which is shown in red here, then I can define gravel and sand, for example. And this is automatically filled here with the color and with the symbols. The color is a little lighter than this one of the bore profile. This can be selected in a configuration. Here the configuration of DCSECTION. We can lighten the colors by 50%, for example. So it is somewhat lighter than the color here in the bore profile. In addition to these polygons, we can use splines, so curves for the display of the soil layers. And I can, for example, create a curve here from this point to this point, and there are then 2 control points defining this kind of curve here, and the brown line is the straight connection between these 2 points for selecting the curve later. As well here for the ground surface, for example, we can define here some kind of curve and then make the filling again. And here we can directly select this curve as a whole with this shape here. And then you see the rubber band at the end of this curve. I can select the second one. The rubber band jumps to the beginning of this curve. And I go back to the starting point and fill this with sand. And then the same again for the next layer. I can take these points here and fill this with clay. And this, as I told before, this may be arbitrary polygons. So here within this silt layer, there might be some lens. This one filled by clay again. So this is any graphics that we want to use here. We can add lines, text, symbols, and so on to this plan. This is a direct construction of the longitudinal section, and as an option with the full version of the program, we can use a plan. And for example, if we create here a new plan, P2, which should be a site plan in the same size. And now we are not in a section, but in a map. We look from top to this area, and there may be any graphics here. We can draw streets, for example, and so on. And now we can again define where our bore profiles are located. So the type bore profile, select project file, select the first borehole log. This should be located at this position. Now you see a different display because this is not a section, but this is a map. And again, with the reference point here we have now a distance x and y from the coordinates. So this bore profile is again shown at the correct position. Okay, here we are outside of the plan. So we have 3 bore profiles, and we might add a dynamic probing as well from the DC probe project file. And this should be at this position, for example. Now this is our map, our plan. And now we can construct section lines, for example, like this. This should be a section AA. And we want to create a longitudinal section along this line here. So we can use the automatic section now. This is this function here, automatic section. I can tell the program that we want to use this section line. And now we have different options. We can project all tests on the section line, which means that following this line, this bore profile is positioned here, this profile is positioned here, this dynamic probing is positioned here, and so on. As an alternative, we can run the section line through all tests. This means that the line would go automatically to this test here, here, and so on. And here we have the exact distances between the different tests. Or option 3 is if we go with a section line directly through different test points, we can tell the program to use only tests on points of the section line. So this way we can select special tests which should be used or should not be used. Now, if we create a section and there's not enough space between the different bore profile, we can use automatic shifting of tests, which means that they are moved according to the space which is needed for the display of the bore profile, and the correct position is shown in the graphics. Now, if we click OK, we have the cross scale for the dynamic probing, for example. The program shows us which heights do we have, which length we have for this section, and asks for the scale to use for the longitudinal and depth scale. And now suggests a sheet size which is large enough for this section that you want to display. So if we combine A1 with A3 in landscape orientation, this would be the right size. And now you see that the program automatically creates this section with all the different tests. And there was no shifting required because we have enough space here between the different bore profiles. If this bore profile would be at this position here, it would be shifted, moved by the program to a position where there is enough space, and the theoretical position here would be marked with a line and the test name. So we have the longitudinal section automatically from the different tests, and the program shows automatically a legend of all the soil types which are used in this plan. You may change this in the configuration to show all the soil types available, but the best option is normally just to show the types which are used in this plan, so this legend is not too large. Now we created an automatic section here and want to know where is the section located on our plan. So what we can do is to integrate the map that we used in this plan. And this is the function which is called insert layout here. I can select, this was plan number 2, which was our map. I can choose to integrate this map in a free size or in the original size as it was drawn in this sheet. So we have not too much space here, so we use free size, and we can define that this plan should be integrated here at this position. By default, this is only shown as a gray area because this might be too slow for display if this is a very, very complex map. And we can change this in the configuration again under DCSECTION. Here the imported plans to show us to display them full. And now we see here the map that we used and where our section A is located. So this map, this plan is inserted here in this very small area to have an overview where this section is coming from. And here again, we always use the original data. This means if we go back to this plan, P2, and we add something to this plan, for example, there should be some buildings. We can create a rectangle here. We fill this with a certain color and add some hatching here. And there should be another building here. And this is as well filled with a color and hatched. And now we go back to our section that we created. Save the graphics. And you see automatically we have here the latest plan. This is integrated automatically with the latest data for the original plan and shown here in the section. So far for the import of the different plans. This can be used as well for a combination of different plans. If we have, for example, you have many long sections which have not a big height, we could combine these plans to a larger one. So I define a third plan here as a longitudinal section with an A0 landscape. And now I can insert different plans here. So I can define P1 with original size. Then I see the size of this plan and can move it to a special position. This is the complete plan P1 that we constructed. And if we use P2 as original size, this is overlapping now a little, but just to show it, here we have P2, which could be moved here with its reference point, the red one. This is going over the margin. So this way we can define different plans on one large sheet. One thing is important is that we have to consider which size we need, which space we need for the different profiles and tests. So before we create the longitudinal section automatically with an automatic function, we can change the configuration. Now we want to change the configuration for bore profiles, so we have to change to the type bore profiles, and then configuration image bore profile, and here we can create or can select the type of display. For example, we switch off long texts, probes were switched off here, water levels can be switched off, and this defines which space we need for this bore profile. For example, if the width of the layer lines here is only 2 centimeters, and for text as well, we need less space here, and this may free some space for the automatic section to have many bore profiles which are very near to each other, displayed without overlapping and without shifting them to a different position.